Elliott. So I'm happy to be here today to talk about our vision of the lab of the future, which is really about creating software infrastructure that lets you work with any scientists anywhere as easily as you could work with the scientists in your lab next door. Just to give a bit of background to myself, I'm a scientist by training. I have a PhD in cancer biology, and then started Science Exchange when I saw that more and more of the work we were doing was becoming so specialized that we really needed to form collaborative networks in order to actually get these experiments done efficiently. And the infrastructure to do that is very ineffective. So just relying on people you know, or setting up individual agreements, or trying to work with people through even now like box sites for each individual partner is actually quite challenging. And so we had this idea of creating this marketplace where we could provide the infrastructure to make that really seamless. So I wanted to start just with an overview of where the industry is today, because I think it's important to look at how transformative we really need to be when we think about the lab of the future. So these numbers indicate that the pharmaceutical industry is really in terminal decline, and we're seeing that the return on the investment that's being made into R&D is now effectively at zero. So in the last 8 years, we've seen a very significant decline in the return on the investment that's being generated for R&D. And I think, when I first looked at this data, I think a lot of people sort of thought about the law of diminishing returns, where maybe all of the best candidates are already taken, and it's just a matter of we're scraping the bottom of the barrel, or we're looking for rarer and rarer indications that will obviously yield lower returns in the commercial setting. But I think when you look at also the technological innovations that have occurred in that same time period, you would anticipate that there's actually a counterbalancing effect where we're able to actually address targets that were previously inaddressable. And obviously, Moderna actually has such an interesting talk previously where that's kind of a core area where we see all of these new types of technologies that can be applied to these targets. And so you would hope that that would actually address this decline in productivity. So I actually think it's also really interesting to think about what the core driver of ROI is. And one of the core drivers is actually speed. So when you think about ROI and how you can actually get a return on the investment of that capital, one of the core drivers of this declining productivity is the increasing length of time at which it takes us to actually go from discovery through to commercialization. And so what I want to talk about today is how can we actually break that R&D speed limit so that we can start to turn around this poor ROI curve. And so in some ways, that's actually just a very tactical question. What are the barriers? Why is R&D actually getting slower? So the actual time at which it takes to go from discovery through to commercialization is effectively increasing every year. And so some of those reasons are that we're just living in an era of increasing hyper-specialization where it really does come down to it's slow if you're going to learn how to do everything yourself. It's slow if you have to get access to every instrument or every research model yourself. And so one of the core concepts that we've been working on is to rely on networked R&D. So this concept of working with the best person at the right time through a network of potential scientists that isn't limited to your own institution or your own lab. And this obviously has numerous benefits, but some of them are listed here. Access to expertise, so the ability to quickly work with somebody who's a true expert. And some of these technologies and techniques could take decades to actually become highly proficient at. And so really working with the right partner is highly beneficial from both a quality and speed perspective. Reduced costs, so I think it's interesting to think about this network of scientists kind of like the cloud, where you want to spin up certain experts at a given time, but it would be cost prohibitive to have all of those in your own facility. And then increased speed, so really the idea that you can just on demand turn something on and then turn it off when you no longer need it. So this idea of networked R&D is really a concept that could be transformative in terms of increasing the speed of R&D. But there are a lot of friction points to actually making this possible. So some examples of that are provider discovery. So the actual ecosystem of potential partners is now very, very large. I thought it was interesting when in the previous talk we had that just anecdotal conversation of who's the best person for Sanger sequencing. And I think that happens every day, but it's really this reality of how do you know? And there isn't really a way to know unless you have previous experience of working with many different providers. So this ecosystem continues to grow just as fast as the biotech ecosystem does. So now over 10,000 CROs and CMOs exist in the world. 77% of surveyed R&D leaders said finding actually reviews and how you can determine quality of providers is really challenging. And even just finding people who have very specific expertise in a therapeutic area can often be a challenge. Other friction points are things like the incentives and ownership of the research that's being conducted. So this is obviously very important, particularly in the commercial setting, where you want to make sure that confidentiality is ensured and intellectual property is protected. And this is something that people generally find is one of the major concerns when they're thinking about working with an external scientist from their own organization is, how will I ensure that IP is protected? Logistics. That beautiful logistics that was built by Moderna is obviously very, very impressive, but I think for the most part, the challenges associated with material transfer, security of data, how you actually track projects, that's something that is very challenging, particularly with large networks of providers that all have individual ad hoc processes that are set up for individual scientists that are working with them. And just one data point around GDPR compliance, which is a recent regulation that came into effect around the protection of EU citizens' data. Already, there's been over 90 companies fined for non-compliance with this requirement. And this is something that increasingly we look at as how do you provide the software infrastructure that ensures compliance with things like GDPR, HIPAA, 21 CFR Part 11, all of these different sectors that need to be protected. You are dealing with individual infrastructure requirements with every external partner that you work with. And so close to 80% of R&D leaders when surveyed felt that they were actually challenged to really even understand how their external partners complied with these types of regulations. Time costs, so this is obviously one of the core ones around R&D productivity, which is every time you work with somebody externally from your organization, if you are trying to protect intellectual property and confidentiality, then you need to establish legal contracts that actually protect that information. And so establishing a legal agreement generally takes weeks or months. And so every time you establish an agreement, you're really delaying the time in which you can initiate this work. And so that then, in turn, really feeds into this concept of, although networked R&D could actually break the R&D speed limit, a lot of the time the friction points that are generated from the actual tactical components of working with external partners really negate a lot of the benefit. And the last friction point is complex project management. So this idea of every partner that you're working with, some of these projects can take years to complete, and so actually keeping track of them and making sure that everything is being recorded and not managed through email, which is a very common tool, is often very challenging for organizations. So in terms of those friction points, it really does create a speed limit that means that you can't really take advantage of networked R&D to really improve that R&D productivity unless you think about the infrastructure that supports that type of approach and use that to make it effective. And so what we really thought about was, can we actually create a system that can break the speed limit through making it as easy for scientists to work with a global network of partners as it is for them to work with the scientists in the lab next door. And so this is the concept of R&D marketplaces. So Science Exchange provides an R&D marketplace where there are thousands of different partners who have already been pre-qualified and pre-contracted, and their capabilities indexed in a large database. And so what that means is that when a scientist comes through Science Exchange, they can search for any of the capabilities that they need. They can initiate requests electronically, and they can work with those providers instantly because they do not have to set up a separate agreement with each of them. And then they can track all of those projects in a project management system that has integration with data transfer and increasingly third-party applications like LIMS systems and file storage systems like Ignite. And so this means that this just shows how it really works, is that scientists can go on, search for over 7,000 different capabilities, and they can start those projects instantly. They can compare provider ratings. So by using a central marketplace, you're able to capture performance across a large number of different scientists working with these providers in a structured format. So we actually aggregate all of the information around performance, both from a subjective perspective, but also from a timeline and quality perspective. So those pieces of information are available so that you can make a qualified decision about who is best to work with. And then when you actually want to start a project, all the infrastructure is already in place. So you don't have to do an IT security review, you don't have to set up a separate folder to actually exchange data files, and you don't have to figure out how to set up collaborators that track all of the different interactions. This is all just done through the Science Exchange platform. So that really frees up the scientists from having to think about every one of those partners they're working with, how they can actually do that effectively. So increasingly, much of the industry is actually adopting this model. So most large pharmaceutical companies use R&D marketplaces for managing outsourcing. And we're starting to see the biotech industry also step in and say, yeah, this is a model that could really enable us to be really efficient and effective. And I think increasingly this concept of competitive disadvantage exists where if your scientists don't have access to this network where they can work with anybody instantly, it does become a disadvantage to the organization. So some examples of our clients, we have large clients like pharmaceutical companies who work through the platform to really use it as a system where their scientists are in compliance with internal ordering policies, where they are able to consolidate hundreds of different interactions through a single platform. And so that obviously drives very significant gains in time savings. So here, estimates of over 10,000 hours saved from their scientists in the first year that they use Science Exchange. But also for me, what's exciting is to see the innovation piece. So for this organization, 37% of their orders were actually placed with new innovative service providers that they hadn't worked with previously. And so that really opens up this world of discovery that would have been prohibitive in terms of the time delays that would have been incurred if they had to establish contracts with each of those partners. And in terms of efficiency gains, one platform that is used to manage the qualification, contracting, and payment processing for all of these different vendors. So there's really significant operational efficiency that the organization is able to achieve there. We also have examples from SMB biotechs where these companies are leveraging the platform to actually increase the speed of individual project initiation and overall then looking for ways to decrease the time at which it takes them to get to key milestones for those assets. And this is just one example where Forma Therapeutics actually quantified each stage for each of their different components of their external partnerships, and were able to demonstrate a 60% improvement from their first request to actual project completion by using the software. And this example is actually a very small startup that was really just starting and entering the market with this very interesting concept of creating a connected medical device that would be used to create a standard connection for bionic limbs. And that is an area of, as you can imagine, very few and highly specialized providers that could actually help them conduct that research. But by using Science Exchange's network, they were able to find who are those few people and identify the ones that had availability to conduct those really critical preclinical studies immediately for them. So our concept of the lab of the future, which I guess is already here, as Elliot would say, is that you really do want to create infrastructure that removes the barriers for scientists to work with the best potential partners so that they can then really free up and improve their R&D productivity by using on demand the right expert for the right task. But increasingly, I think that we'll see this reliance on externalization become the predominant business model by which people conduct their R&D. So we've already seen in the last 15 years a dramatic shift in actual R&D expenditure, where it now approaches close to 50% of R&D dollars are actually spent with these external partners, and there are more scientists employed in CROs and CMOs than in biotech and pharmaceutical companies. So that's actually a very interesting stat to see that shift occur. And we believe that more and more automation will exist in how people actually conduct the experimentation, collaboration, decision-making, and communication of results. That automation needs to be integrated in a single platform for it to truly be effective. So we are really excited about the concept of building the infrastructure that provides a workflow layer where scientists can work with anyone through this workflow layer, but then above the R&D services marketplace, they can actually integrate with things like procurement platforms, their data repositories, and increasingly their LIMS systems, their regulatory guidance and databases, their ERP systems. And so overall, you end up with an infrastructure layer that allows the scientists to be incredibly efficient at their work because they're not thinking about all of the administrative tasks they have to do in order to accomplish their R&D. And so we believe that this will create a model where we can break the R&D speed limit by actually enabling these scientists to use a truly networked approach to be very, very efficient at bringing their drugs to market. Thank you. I'm happy to take questions.